Even if you don't own one, you probably know the Snap-on MT2500 scanner on site. Tens of thousands of these bright red scan tools have been sold, and there's a good chance that even if you don't have one yourself, you know someone who does. The controls on the Snap-on scanner are extremely simple. All user inputs are entered using the thumb wheel and the yes and no buttons. The thumb wheel is used to scroll through the scanner's menu options and data displays. The yes button is used to enter a menu selection, advance through a test procedure, or make a menu choice when a yes selection is required. The no button is used to back up to a previous menu level, control the backlight, or make a menu choice when a no selection is required. There's a third button off to the left known as the Quick ID button. We'll cover Quick ID in detail in the next section. If we look at the top of the scanner, we can see the main cable receptacle. This is the port where the vehicle interface cables and power pack plug in. To the right, there's a small telephone jack used to connect the scanner to a personal computer or printer. There's also a small 9-volt battery located beneath the left hand grip for the Quick ID function. The battery powers the scanner during the Quick ID setup, and a low battery indication will appear on the scanner screen if the 9-volt battery gets low. Coming up next, we'll look at the Quick ID function and the scanner's demonstration mode. The scanner's Quick ID function does pretty much what its name suggests. If you press and hold the Quick ID button, the scanner will walk you through the vehicle identification process so you can enter the correct VIN numbers and tell the scanner about other vehicle characteristics like whether or not it has air conditioning or automatic transmission. You'll need to hold the ID button down until all the required vehicle identification data is entered. At the end of the Quick ID process, the scanner will tell you in advance where to find the vehicle's diagnostic connector. Once the Quick ID procedure is complete, you can release the Quick ID button and the scanner will remember your choices until you change them. The scanner also has a demo mode available through the 3-in-1 cartridge that you can enter through the Quick ID setup. First-time users can view a simulation of live vehicle data in demo mode. Let's walk through the Quick ID process to show how it works. Instead of using the vehicle identification numbers from a real vehicle, however, we'll be using the special characters that take you into demonstration mode. During a normal vehicle setup, you'd use the numbers from the vehicle identification sticker. Entering vehicle information during the Quick ID process is just a matter of following the prompts on the scanner screen. When the Quick ID screen first comes up, you'll see display lines indicating the currently installed cartridges. If the cartridge currently installed is not the one for the vehicle you're working on, stop right here and change to the correct cartridge before proceeding. The next screen identifies the OEM choices supported in the installed cartridge and the years of coverage. Here we have a 3-in-1 cartridge that supports GM, Chrysler, Jeep, and Ford. New Features is a special category that identifies any new or improved software features available in this cartridge. OBD2 is the selection you'll want if you're going to retrieve codes and data from 1996 and newer vehicles. We'll come back and talk about OBD2 a little bit later. For our demonstration purposes here, however, we're going to go ahead and select GM and Saturn and enter our choice with the Yes button. Once we've entered the OEM section, we'll be asked to make some more choices. Available choices such as engine or ABS will be listed in the display window. Now we're going to go ahead and select engine for our demonstration. Now we have to start entering the VIN numbers. In this GM VIN selection process, we'll need to enter the 3rd, 8th, and 10th VIN numbers. As each highlighted VIN comes up, scroll through the choices with the thumb wheel and hit the Yes button when the correct letter or number is displayed. This automatically takes you to the next screen so you can continue the process. The letter combination shown, 1MD, takes us into demonstration mode, and we'll be discussing this more as we go along. Finally, we'll be prompted to identify any accessories such as automatic transmission or air conditioning to complete the ID process. Once we've entered all the ID data, the scanner will tell us which scanner connector we need and where to look for the vehicle's diagnostic connector. At this point, we can release the Quick ID button. The selection will stay in the scanner's memory until we change it. The scanner is now set up and ready to connect to the vehicle. Demonstration mode is a great way for scanner users to familiarize themselves with controls and features that improve the scanner's usefulness as a diagnostic tool. If you'd like to spend some time browsing scanner features in demo mode but don't want to sit there holding the Quick ID button down during the learning process, you can fabricate a small power supply with a 6-wire phone cord and a 9-volt battery adapter. Connect the battery adapter wires to the 2 outer wires on the phone cord. The remaining 4 wires in the phone cord aren't used. Then connect the adapter to the scanner's phone jack. Now the scanner will power up without your having to sit there and hold the Quick ID button down. You can make 2 of these little power connectors out of a single length of double-ended 6-wire cable. Connect the blue and white wires to the red and black battery leads. Just remember that the blue and white wire colors will be reversed on opposite ends of the same length of double-ended cable. This diagram illustrates wire locations. In other words, with the phone jack locator tab at 12 o'clock, the blue or white wire to the left will be positive and the blue or white wire to the right will be negative. This schematic shows the correct hookups for both ends of a double-ended 6-wire phone cable. The scanner comes with an assortment of dedicated cable connectors. Dedicated cable connectors are vehicle-specific and are designed to plug into the vehicle diagnostic connector on GM, Ford, and Chrysler and Jeep. These are the standard cable interfaces for pre-OBD2 vehicles. On most pre-OBD2 vehicles, you'll need to power the scanner by connecting an external power lead to either the battery or cigarette lighter plug. The power leads plug into a receptacle in the side of the dedicated connectors. 2 exceptions to this rule are the Chrysler 6-pin C2D and Jeep dedicated connectors. Neither of these interfaces requires an external power supply since power for the scanner is provided at one terminal of the vehicle's diagnostic connector. If the vehicle's battery is inaccessible or the cigarette lighter plug is damaged or inoperative, you can plug the scanner's power pack into the main cable port and connect the interface cable to the power supply. The power supply contains a rechargeable battery. To conserve the power pack and extend the intervals between recharging, you can turn off the scanner's backlight by pressing and holding the No button until the light goes out. Reverse the procedure to turn the light back on. Just hold the No button until the light comes on again. OBD2 vehicles require the special 16-pin diagnostic link connector, or DLC for short. No external power supply is needed. The vehicle's diagnostic connector provides the power and ground for the scanner on all OBD2 vehicles. If you want to look at OBD2 diagnostic trouble codes, freeze frame, data stream, or monitor readiness status, you'll need to select OBD2 from the main scanner menu and then use the OBD2 connector cable end. The OBD2 cable interface won't work properly until you install something called a personality key. Personality keys identify the vehicle being tested to the scanner. Each key is numbered and they slide into a slot in the cable end connector body. You have to install the correct key, but the scanner will tell you which one to use during the Quick ID setup. For example, if you select OBD2 from Quick ID, the scanner will tell you to install key number 2. This takes you into what is known as generic OBD2. Generic OBD2 is the interface that should enable you to view and erase 5-digit OBD2 DTCs, look at freeze frame and OBD1 data parameters, and also access the status list for all OBD2 monitors installed in the vehicle. Can we still connect the scanner to the OEM interface even though we have an OBD2 vehicle? You bet, but we have to install the correct personality key to do this. The question is, which one of the keys do we need? The procedure for connecting the scanner to the OEM interface on an OBD2 vehicle is really very similar to the one we used on pre-OBD2 vehicles. Just select the OEM from the list, and we'll use Jeep as our example here. Identify the vehicle by entering the correct VIN numbers. When you're done with the Quick ID process, a new screen will appear that indicates which personality key number to install in the OBD2 connector. Once again, the Quick ID process does more than set up the scanner. It tells us which cable end and personality key we need to connect the scanner to the OEM interface on an OBD2 vehicle. The last cable we need to discuss is known as the Multi-1. This cable has individual wires that are inserted into diagnostic receptacles when you don't have the required dedicated terminal ends. Use the reference manuals that come with the scanner or follow on-screen scanner displays to match Multi-1 wire colors to the correct terminals in the diagnostic connector. The Multi-1 is most commonly used with Asian makes. The scanner receives its operating instructions from its cartridges, and there are two basic types, the primary and the troubleshooter. The primary cartridge is responsible for connecting the scanner to the vehicle data line so you can view codes and data stream and perform bidirectional tests. There are several special primary cartridges available for the scanner, including ones for Asian imports and a new cartridge for Mercedes-Benz vehicles. Cartridges are updated periodically to keep the scanner current with new makes and models. There isn't a fixed time schedule for releasing these updates, so the intervals between the updates will vary. One way to update a cartridge is by installing new chips. This method is less expensive than replacing the entire cartridge. Installing new chips is as simple as removing the cartridge cover and replacing the old chips with the new ones containing the upgrade software. Each upgrade requires 2 chips, and you'll have to send the old ones back to Snap-on. The chips have to be installed facing in the right direction. Each chip and the circuit board will have directional arrows to show you which way the chips install. Install the chips carefully, making sure all of the tiny chip connector pins are properly aligned in the receptacles in the cartridge circuit board. Then press down evenly to seat the chip in the board. If you skip an upgrade when the next upgrade after that is issued, you'll have to spring for a whole new cartridge, so there is some financial advantage to keeping your scanner up to date as each new set of chips is issued. Troubleshooter cartridges are sold separately. They don't need to be installed for the primary cartridge to work. In other words, if you have the correct primary cartridge installed, you can still connect the scanner to the vehicle and pull and erase codes and view data stream. Troubleshooter cartridges are simply an added source of diagnostic help. Several versions are available to help us when we troubleshoot systems like powertrain, ABS, and automatic transmissions. Here's the main menu for our GM vehicle. This time we'll scroll past codes and data and go directly to Troubleshooter. Then we'll hit the Yes button to enter the Troubleshooter menu. The first item in the menu list is an introduction describing the features in the Troubleshooter cartridge. It's an overview of Troubleshooter features. The other menu options include sections called Code Tips, tips listed by vehicle symptom, tests and procedures, technical assistance, and finally an item called Fast Track Data Scan that lists nominal values for various data parameters. Now that you know how the menu is set up, let's place the scanner in demo mode and look at each of these features to see how Troubleshooter can help you repair vehicles. Okay, now let's switch over to Ford for a moment and look at several Troubleshooter features in more detail to give you a flavor for what's available. Let's start with Code Tips. If we hit Yes in the Code Tips section of the menu, we go to a list of common trouble codes. Now we're going to select code 21 ECT for this demonstration. The next display will warn us that test conditions must be right before we can properly run the key-on engine running test. It cautions us to make sure the engine is fully warmed to avoid setting a false code during a vehicle self-test procedure. One more scroll of the thumb wheel takes us to a display that identifies the wire colors at the coolant sensor and also suggests normal voltage ranges for a warm sensor. The next display offers quick suggestions about how to interpret sensor voltage values that fall outside the normal range. Code Tips, regardless of manufacturer, is designed to provide component identification and quick test procedures for major sensor inputs. Now let's go back to the Ford main Troubleshooter menu and see what else we can find. Another useful troubleshooter tool is something called Symptom Tips. The Code Tips option is designed primarily to provide a diagnostic path when codes are stored in the PCM. But there are times when a vehicle exhibits drivability symptoms without storing any code at all. Symptom Tips allows us to match up a symptom with a list of causes and fixes. When we first enter Symptom Tips, the first item is labeled Abbreviations Used. If you have an abbreviation you aren't sure of, you can always stop here and scroll until you find the abbreviation's description. Then when you're done, simply hit No to return to the Symptoms Tips menu. Then scroll down the list until you find a match for the vehicle symptom. We'll select hesitation on acceleration misfire as our example here. The scanner lists 3 possible causes for this symptom and treats other symptoms in similar fashion. You don't have to limit yourself only to code or symptom tips. In fact, it's often helpful to cross-reference vehicle problems by code and symptom to speed your diagnosis. Once you've used code and symptom tips to identify likely causes for a vehicle problem, the next logical step is to begin testing any suspect circuits. Troubleshooter's Tests and Procedures section is designed to provide you with specific test procedures and specifications. Think of it as a reference library containing the test values and procedures you need to continue pinpoint tests without having to hunt down this information in an external reference manual or database. The items in Tests and Procedures vary by vehicle manufacturer and scanner software version, but here are a few items you'll find in a typical Ford Tests and Procedures menu. Similar features are available in the Tests and Procedures menu for other makes. The Technical Assistance and Abbreviations menu has all sorts of useful information in it. We're still in the Ford section and we can see several options available, including Bulletins, which includes a list of common tech service bulletins and their numbers, Reference, which includes factory reference specification charts and their numbers, Connector Locations and Pinouts, which lists terminal numbers and pin identifications for things like the TFI module, EEC Self-Test Connector, and the PCM 60-pin connector. We'll come back to this in a moment. Conversion charts. In this troubleshooter cartridge, we find a baro and map frequency conversion chart so we can compare actual manifold vacuum and pressure readings to recommended frequencies for either the map or baro sensors. Finally, Information Tips provide supplemental information on how to incorporate all of these specifications into our troubleshooting procedures. Let's go back and take a closer look at the Connector Locations and Pinouts option. When we select this in Ford, a new menu lists 3 choices for us: the TFI ignition module, EEC self-test, and PCM 60-pin connector. Now we're going to start with the TFI module. The first screen identifies the module and connector and tells us their general location. It also instructs us how to view the schematic we're about to see. When we scroll to the schematic, we see the locator tab on the connector and each of the TFI module's 6 pins. Then as we scroll further, each pin at the connector is identified for us. Similar schematics are included for the EEC self-test and PCM 60-pin connectors. If you choose the PCM connector option, you can walk through all 60 of the EEC4 connector pins and identify each by circuit and location inside the main connector body. We can't go through all of the Troubleshooter features here, but the Troubleshooter cartridges are time and step savers. Menu options will vary slightly by model and also by the version of the Troubleshooter cartridge you have installed. Just remember that a lot of the reference materials you need for most repairs can be found right inside your Troubleshooter cartridge. You can't really get the most benefit from your Troubleshooter cartridges until you understand what they'll do for you. We suggest that you make yourself a small battery adapter, sit down somewhere quiet, enter demo mode, and then just roam around in the Troubleshooter menus for Ford, GM, and Chrysler until you know what each one has to offer. We think that once you start using these added features, you'll wonder how you did without them. Next up, we'll look at how to view codes in DataStream, how to freeze lines of data, and how to set up and interpret those flashing LEDs. Once the Quick ID setup has helped us identify the correct interface cable and locate the vehicle's diagnostic connector, we're ready to connect the scanner and start collecting data. If you change your mind, you can enter a new vehicle ID by hitting the No button and entering new vehicle VIN data. But we're going to accept this ID and just hit the Yes button to continue. Next, we get to a menu that lets us select the system we want to scan. As you can see, we have a number of choices, including engine, ABS, body, or airbag. We'll use the thumb wheel and scroll back to engine since that's what we'll be using here. The Codes and Data menu lets us view hard and historical codes as well as data stream parameters. Functional tests vary by vehicle. On this GM, the functional test menu includes selecting field service mode and also includes a throttle position test and adjustment procedure. Custom setup includes items like configuring the LEDs on the scanner or switching from English to metric measurement. We can also use this setting to set up the baud rate for connecting a printer to the scanner. Troubleshooter will appear only if the Troubleshooter cartridge is currently installed in the scanner. The Other Systems option simply returns us to the previous menu level. For our demo, we'll stick with Codes and Data and make that selection with the Yes button. The Codes and Data display comes up next. The very top line includes RPM, oxygen sensor voltage, and integrator values. The parameters displayed on the top line may be a little different on other makes, but the important thing to remember is that line 1 will always be visible in this location at the top of the screen. The next thing we come to are any hard codes stored in the PCM. Right now this vehicle has a hard code stored for the engine coolant temperature sensor. Hard codes are those the PCM sees right now. Then we come to something GM calls historical codes. Historical codes are faults that have been seen by the PCM at some time in the past. They may or may not be present right now. This vehicle seems to have both a hard and historical code for the engine coolant temperature sensor. As we scroll down further with the thumb wheel, we begin to see data parameters displayed. Note that the top line is still showing RPM, O2 sensor voltage, and integrator values. The scanner will display 6 scrolling parameters at any one time, and as we scroll, the list moves up, one row at a time. Scroll data lines looking for data values that indicate a problem. Try to concentrate on any data items related to hard or historical codes, such as our -40 degree reading on the engine coolant temperature sensor. Normally, when we scroll through the data lines in the Codes and Data display, we'll see that line 1 stays fixed at the top of the screen. Then, as we scroll, we'll see the data on lines 2, 3, and 4 change with each click of the thumb wheel. This is the scanner's default data display setting. Sometimes, however, we may want to lock additional data items on the screen. Let's say we think we have a mass airflow sensor problem that's affecting the injector pulse width, and we want those 2 parameters to stay on the screen even as we scroll through the data list. We can position mass airflow and pulse width parameters on line 2 and then lock line 2 so only lines 3 and 4 will scroll when we move the thumb wheel. To lock line 2, just hit the No button once to back up one screen. Use the thumb wheel until the arrow aligns with Fix Line 2 and hit the Yes button to enter your selection. This locks line 2 and takes us back to codes and data. Now when we scroll, only lines 3 and 4 change when we move the thumb wheel. Now we can fix line 3 as well. Hit the No button again to back up to the menu display. Here we see we have a choice to either release line 2 again or fix line 3 as well. Let's choose fix line 3 and hit the Yes button. This takes us back to codes and data again, and we can see that lines 1, 2, and 3 are now fixed in place. When we scroll, only line 4 changes. Line 4 can't be fixed. Want to release lines 2 and 3? Hit the No button one more time to back up one menu level. Select Release Line 3 and hit Yes. We return to codes and data and see that both lines 3 and 4 now scroll. Only lines 1 and 2 are still locked. To release line 2, we hit the No button one more time. Return to the menu, select Release Line 2 and hit the Yes button again. Hitting the Yes button again takes us back to where we started. Only line 1 is locked, and once again, when we scroll with the thumb wheel, lines 2, 3, and 4 all scroll again. You can lock or unlock lines 2 and 3 at any time using these simple procedures. The scanner's LEDs can also help us gather some quick information without the need to study data lines. Each of the scanner's 4 LEDs is triggered by an event in the vehicle data stream. 2 of the 4 LEDs are triggered by closed loop and rich exhaust conditions, but LEDs number 3 and 4 can be user defined. Let's look at this feature more closely. Normally when we view codes and data, we can see the LEDs flashing on and off. If you can't remember what they mean, just hit the No key from the codes and data display to back up one screen and display the configuration menu. Scroll with the thumb wheel to align the selection arrow with the menu item named LED and hit the Yes button. The next screen will display LED numbers and their designations. L1 will always illuminate when the system goes into closed loop, and L2 will always illuminate to indicate a rich exhaust condition. These two, L1 and L2, will always represent these conditions and can't be redefined. L3 and L4 can be defined by you. Note that L3 has an arrow next to it indicating that it can be changed. Use the thumb wheel to scroll through the menu options until you find the vehicle condition you want to have controlling the LED, and then hit the Yes button to enter your choice. Now, L4 is highlighted by the arrow. We'll select Torque Converter Clutch activation to control LED number 4 and hit the Yes button again to return to the codes and data display. When we return to the codes and data display, we know that L1 and L2 stand for closed loop and rich exhaust. Anytime you can't remember what was selected for L3 and 4, you can return to the LED menu to change or view your selections. Long lists of data can be very difficult to evaluate, especially when we're trying to keep track of dozens of constantly changing live parameters in the scanner's small display window. Fortunately, the scanner can also be used as a movie camera. It has special data capture features that allow us to grab single snapshots of data, record multiple frame movies, and then review single or multiple frame data lists at our own pace. That's what this section is all about. We've broken the procedures you'll need into a step-by-step animated graphic sequence, and we'll walk you through these procedures. Let's start our look at special scanner features with a simple procedure for freezing data stream called the hold function. Basically, the hold function can be used to freeze data in a single frame snapshot that remains frozen until we decide to return to live data. We can use this stop action feature at any point as we view data stream. The hold function works in codes and data. To get there, we select the system to view, and this time we'll select Engine and hit the Yes button to enter our choice. This brings us to the main menu, and since we want to look at data stream, we'll select Codes and Data and hit the yes button one more time. Arming and taking a movie is a simple process. Here we see a standard data display in a vehicle that has an intermittent problem. What we'd like to do is take a movie, but we'd like to trigger right on the instant the problem occurs. Anytime we're in codes and data and want to take a movie, all we need to do is hit the No button once. This will take us back to a new menu with several features, but the one we want right now says ARM Movie. So let's scroll down with the thumb wheel to select it and hit Yes to enter our choice. As soon as we hit the Yes button, we see another screen warning us that taking a new movie will erase any movie currently stored in the scanner's memory. The scanner can store only one movie at a time. As soon as we hit the Yes button from this screen, the scanner starts recording. This part's important. The scanner begins recording data even before we trigger the movie. Okay, let's hit the Yes button there, Chief. Now, as soon as we hit the button, the data screen reappears and the word ARM is displayed in the upper left-hand corner of the display window. What's happening here? Well, the scanner is already recording. All we have to do is hit the Yes button to trigger the movie when we feel the drivability symptom occur. Hitting the Yes button right at the instant when that drivability symptom shows up marks the frame in the movie where the event takes place. The word ARM in the upper left changes to numbers as the scanner begins recording frames that occur after the trigger point. We can see the numbers climb from 0 to 25, and then the scanner displays the word END to indicate that the movie has been stored in memory. Okay, our movie is stored in the scanner's memory. To review the stored movie, we'll need to back up a couple of screens, but that's easy enough to do. We hit the No button to back up one menu level, and then hit the No button one more time to return to the main menu, and that's where we're going to find the Review Movie selection. We scroll to select Review Movie and hit the Yes button to enter our choice. Frame 0, our trigger frame, comes up first, and we can scroll through all the data lines in Movie Frame 0 with the thumb wheel, just as we would do with a single snapshot capture. Once we've looked at all the data lines in frame 0, we can go ahead and move to any other frame in the movie that we want to choose. To do this, all we have to do is hit the Yes button once. Then, when we scroll the thumb wheel, we'll begin to move through the individual movie frames, one by one. When we get to a frame we want to study more closely, we can hit the Yes button one more time. This locks that frame in place. And then, when we go back to the thumb wheel, we'll be scrolling through each data line in the selected movie frame. Toggling back and forth between data line scrolling and frame scrolling is as simple as hitting the Yes button to change scrolling modes. Let's review. So far we've looked at several different ways to gather and view data right on the scanner display screen. We've captured individual frames with the hold function and stored and reviewed movies. But the scanner window is limited. It can display only one frame and 9 data parameters at a given time. Snap-on offers a software program called Scan Graphics that allows us to download either live or recorded data to a computer and then display 7 data frames at one time on the computer monitor. Each of the frames will display 19 parameter lines instead of the 9 we normally see in the scanner display window. Once Scan Graphics is installed on your computer, you can connect your scanner using the telephone jack interface cable and download your data files through the computer's serial port to the hard drive. Let's look at some sample screens that illustrate how to navigate the Scan Graphics interface and show us how we can use this program to interpret numeric and graph data. The movie captured by the scan tool may run a lot longer than 7 frames, but we can scroll through all of the stored frames and select 7 to view at any one time. Each frame will be numbered. Those with negative frame numbers will have been stored before the trigger point. Frames with positive numbers were stored after the trigger point. Here we're viewing data parameters that have been captured as a data file and downloaded to our computer. We can view each data line over 7 frames and look for glitches or dropouts. Once again, even though we have only 7 frames on the screen at any one time, we can scroll to other areas of the movie using the arrow and page up or page down keys. If rows and columns of raw numbers aren't to your liking, you can also graph data for 4 different parameters on a single screen. Each parameter is identified in the column to the left, and numeric values are displayed below each parameter identification. Scrolling through the data graph is easy. Use your mouse to move the screen cursor over the cursor line. Then click and drag the cursor line from side to side to scroll through the data frame by frame. Scan Graphics also has a special feature called Glitch Snitch. Glitch Snitch scans the data in the file and looks for anything that might indicate a glitch or a dropout. Then it selects 4 parameters it thinks might lead you in the right diagnostic direction and displays them on the screen. Just click on Glitch Snitch in the menu bar to start the procedure. Sure enough, Glitch Snitch has scanned the data files and replaced our original 4 parameters with 4 new ones it thinks we need to study more closely. The benefit of downloading a movie and reviewing it as a graph is that it lets us view several frames at once. In this vehicle, a bad computer is causing frame-by-frame changes in important inputs. We're starting at frame 1 in this movie, and as we drag the cursor line from frame to frame, we can see radical, irregular voltage changes. We might not catch this problem if we were limited to viewing a single data frame on the scanner screen. Looking at several frames at once, however, shows the problem clearly. Let's drop down to the lower left and watch the PROM ID number. It's a little confused. As you can see, the PROM ID is changing from frame to frame, indicating our computer problem. Combine Glitch Snitch and graphs to locate abnormal shifts in computer data. That last example might be a little bit extreme, so let's look at a more typical problem caused by a momentary dropout in a throttle position sensor. The interesting thing about this problem is that the TPS glitch lasted long enough to cause a drivability symptom, but did not last long enough to store code. We decided to take a movie with the scanner, trigger right on the drivability symptom, and then download the movie to Scan Graphics. When we first open the movie data file, we see 4 parameters listed: RPM, oxygen sensor voltage, integrator, and open closed loop status. We run Glitch Snitch and let it pick parameters for us that it thinks might help. And the very first thing that comes up is TPS. Just below the TPS ID, there's a small box indicating sensor voltage for the frame that we're in, and it looks fairly normal. But if we look closely at the graph, we can see that the cursor line's placement right now is right next to a dropout. If we move the cursor over the glitch in the graph and then look back at the numeric voltage value in the left column, we see that when the glitch occurs, TPS voltage drops all the way to ground. This is frame -1, just before we notice the problem and hit the movie trigger. Now let's move the cursor frame 1 frame past the glitch. Notice that TPS voltage returns to about half a volt. Then if we look down the display at idle air control and RPM, we can see that both of these have been affected by the TPS glitch that occurred in the previous frame. Once again, the dropout lasted a single frame and did not set a code. By recording a movie, opening the movie in Scan Graphics, and then running Glitch Snitch, we go right to the problem. So far, you've seen a long list of useful diagnostic tools that are built right into the scanner's special functions, and also looked at data and graph displays in Scan Graphics. Now it's time to list several circumstances where these tools come in handy to help you diagnose vehicle problems in less time. Let's start with the obvious. namely a condition where the PCM has already detected a failure and illuminated the check engine light or malfunction indicator light, as it's now known on OBD2 vehicles. On pre-OBD2 vehicles, go to the Codes and Data menu and look for any hard or historical codes that are stored in memory. Then scroll down the list of data parameters. Look for one or more data lines that are directly related to the code. Our coolant sensor minus 40-degree reading is one example of a parameter that is clearly wrong and indicates an open coolant sensor or circuit as a result. Next, make a written notation of any codes and erase them from the PCM. Restart the engine after you've cleared the codes or drive the vehicle to see if the codes return immediately. If they do, you know you have a hard fault and you should find evidence of it in DataStream. Don't forget that Troubleshooter can help you identify connectors and wire colors in any suspect circuits and also provide you with normal values for comparison to the live data shown in DataStream. OBD2 vehicles require a slightly different approach. For starters, you'll need to use the OBD2 interface to view or erase any 5-digit OBD2 codes. It's also important to view and record any freeze frame data stored with the first or highest priority code stored in the PCM's memory. What's freeze frame? Well, unlike a snapshot stored in the scanner with the hold function, freeze frame is a snapshot of critical engine operating conditions stored inside the PCM. You'll get at least one freeze frame, and the data included can be very useful for diagnosis, since it should coincide with the conditions that stored the code in the first place. If you erase codes in an OBD2 vehicle, you'll also erase freeze frame. So don't forget to view and record freeze frame data before erasing DTCs. Another big difference is that unlike most OBD2 code conditions, there are many OBD2 codes that won't reappear immediately. The vehicle may have to be driven through 2 diagnostic cycles known as trips before some codes will return. Intermittent problems can be a real hassle. Remember that brief problems can cause abnormal drivability symptoms without storing any codes. A glitch or a dropout that lasts for a single frame may come and go without leaving any hard evidence. Look carefully at historical codes. They can lead you to an intermittent condition. Use the Fixed Lines function to lock the most likely parameters in the display window. That way they stay in clear view on the scanner screen even as you scroll through the rest of the parameters. If the vehicle acts up briefly, hit the Yes button to freeze the display right when the vehicle acts up. Then, with your single frame snapshot frozen in the scanner screen, scroll through the data lines looking for clues. If you can't duplicate the symptoms in the shop, have an assistant drive the vehicle while you operate the scanner. Arm the scanner to take a movie and trigger on the symptom right when you feel it. Let the scanner start recording even before the symptom appears. That way you'll have plenty of frames stored before and after the trigger point. The data file we just stored in the scanner during the road test can be thought of as a string of individual movie frames. Each frame is numbered, and individual frames contain the values for all monitored system parameters. The parameters displayed vary by make and even model. There may be over 100 frames in our movie, and we can select the frames one at a time for closer analysis. To review the frames, use the controls we discussed in the Review Movie section of this video to navigate between frame and data line scrolling. Just remember that it can take a long time to scroll through, select, and then study all of these frames individually. So what we need to do is narrow our search so we aren't looking for a needle in a haystack. And this is where the trigger point comes in. The trigger frame will always be numbered 0. If we manage to trigger on or near the drivability symptom, then the trigger frame and the frames immediately before and after the trigger point are logical places to start our search for clues. Negative number frames, those right before the trigger, normally contain data indicating what caused the symptom. Positive numbered frames, or those after the trigger, usually indicate how the system responded to the problem that caused the drivability symptom. So if you're reviewing your movie on the scanner, select the frames closest to the trigger point first, and work outward from that point in both directions until you find data indicating a problem. Most of the time, this approach will save you the time it takes to scroll through all the frames and look at those that can't really help you with your diagnosis. We can use a similar approach even if we download the movie to scan graphics. Run GlitchSnitch and let it sort through all the data parameters looking for potential problems. When it displays likely candidates, start at the trigger frame and gradually expand your search area. Concentrate on frames of data stored just before and after the trigger frame. Now this is also a reminder of how important it is for us to arm a movie, let it run long enough to store multiple frames, and then trigger as close as possible to the vehicle symptom when it occurs. As you can see, the scanner's trigger and movie functions and scan graphics are designed to work together to help us capture, sort, and finally review vehicle data efficiently.